The overall goal of this direct synthetic approach, which is applied here to prepare the marine natural product clevatidine A, is to reduce the number of chemical transformations needed to prepare linear aminoguanidine-containing molecules.
This method can be used to prepare natural and engineered compounds quickly and efficiently to further understand their biology, which may lead to new and better medicines for human health. The main advantage of early-stage guanidinylation is that a masked guanidine can remain intact if an appropriate protecting group strategy is devised to avoid chemoselectivity issues and subsequent reactions.
To begin this procedure, weigh 0.933 grams of 2,4-dibromohomogentisic acid lactone on an analytical balance. Add this solid to a round-bottomed reaction flask containing a magnetic stir bar under a nitrogen umbrella. Add 30 milliliters of anhydrous dichloromethane to the flask. Stir at ambient temperature to dissolve the solid. Next, add 0.103 milliliters of Unix base to the flask by syringe. Cover the opening of the round-bottom flask containing the previously prepared unpurified isocyanate with a rubber septum. Then, connect the flask to a Schlenk line and purge it with nitrogen gas for 10 minutes. To the flask containing the isocyanate, add 30 milliliters of anhydrous dichloromethane. Swirl the flask at ambient temperature to dissolve the isocyanate. Following this, directly connect the two flasks by puncturing each septum with either beveled metal tip of an 18-inch long 20-gauge metal cannula. Remove the nitrogen inlet